Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Sania Nursafitria with number student ID F1C1 23018. I'm from JAMBI University, Facultas Science and Technology with the program Chemistry. So today I'm gonna explain about the stereospecific and stereoselective in a simple way. Okay, let's start it. So what is stereospecific? Stereospecific refers to a chemical reaction where the stereochemistry of the reactant directly determines the stereochemistry of the product. Different stereoisomers of starting material like cheese and trans will produce different products. For example, the addition of bromine to cheese to butane and trans to butane gives different stereoisomeric product. This is different from a stereoselective reaction, where one is stereoisomers is favored to the product but not necessarily due to the reactant stereochemistry. Okay, next. So, what is stereoselective? Stereoselective refers to a type of chemical reaction in which two or more stereoisomeric products are possible, but one is formed in a greater amounts than the others. This preference happens due to the factor like reaction condition, catalyst, or steric effect, rather than the specific stereochemistry of the starting material. For example, in the hydrogenation of an alkane, the addition of hydrogen atom often occur on the same site, or we call it like a syn addition, leading to one major stereoisomeric, unlike the stereospecific reaction, where the product is directly determined by the reactant stereoisomer. Stereoselective reaction is simply favored to the formation of the stereoisomeric than the others. Okay, next we're gonna explain about the stereoselective. So in this slide, a stereoselective reaction is a chemical reaction where the single starting material, or we call it like SN1, yields two possible stereoisomeric as a product, but one is major and one is minor. Okay, for the example, we have an alkane estrate with MCPBA, or we call a methachloroperoxybenzoic acid. It undergoes exfoliation to give two enantiomer in roughly equal amounts of 50-50% each other, indicating direction is not stereoselective. This reaction, it's not stereoselective. However, when the chiral catalyst system such as TiOIPR4 with minus diethyl tartrate is used, the reaction yields one enantiomer, predominantly 98%, proving that the reaction is highly stereoselective. So we can see it in the bottom. We use TiOIPR4 and the ethyl tartrate, so it goes to enantiomer, but different with the others. The enantiomer is not 50-50%, but it's 2% and 98%. This one is stereoisomer of the stereoselective. What is the stereoselective one? It's the 98% one. Okay, next we're gonna explain about the stereospecific. Stereospecific. What is stereospecific? Stereospecific that I already talking about before is the reaction. It's one where the stereochemistry of the starting material directly determines of the stereochemistry on the product. Different stereoisomeric reactant give rise to the different isomeric products. A classic example in this anti-addition of Br2 to alkanes with when its cheese still bane is treated with BR2, the product is a meso compound, or we call it achiral. But when the transtibane is used, instead the result is a pair of enantiomer in a 50-50 ratio. So we can see it like in this slide. Stereo configuration of the starting materials determine the stereo configuration of the product. So if we do the SN1 or SN2 stereoisomeric, we're gonna have a product 1 and product 2 that is the stereoisomer. And this slide you can see it is a stereospecific. It's treated with BR2 anti-addition. It will be a meso compound achiral, but for the SN2 it will be 50-50% of the pair enantiomer. So this demonstrates that the outcome of the reaction is strictly dependent on the stereochemistry of the starting material, making it a stereospecific process. Okay, next we're gonna go in this slide. Stereoselective and stereospecific. What's the difference between these two? The distinction between stereoselective and stereospecific reaction. In a stereoselective reaction, one starting material produces two stereoisomeric products, but one is formed in a greater amount. So the product will be major versus minor product. The choice of the catalyst or condition can affect the ratio. In contrast, a stereospecific reaction, two different stereoisomeric starting materials with SN1 and SN2 produce two entirely different stereoisomeric products. It calls product 1 and product 2. And this outcome is detected entirely by the original stereochemistry. The stereospecificity refers to the one-to-one relationship between the configuration of the reaction and the resulting product. So that's all that I can explain of the stereospecific and stereoselective for you guys. Sorry if I'm making some mistake because I'm still learning too. Thank you for watching me. See you next time, guys. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.
また口に出すもう一度だけ後悔してばっかりじゃんうざ愛してもなんで伝わんないのかな終わりなんて嫌だよやめて好きだけじゃダメ